For section 2.8, we're going to be solving absolute value equations and inequalities. So to start this off, we're going to talk about a disjunction and conjunction. A disjunction is a compound statement that uses the word or. So for example, I have x is less than or equal to -3, or x is greater than 2. In set builder notation, we are going to have both inequalities in there, and we're going to use the word or the letter U in place of the word or. So if we were to graph this on a number line, it would look like this. In our first one, we're going to look at just this inequality here. So a circle at -3. That inequality is underlined, so we want to include our -3 as part of our answer. And x is less than -3, so less than goes to the left towards the smaller numbers and shade that line in. Then we're going to look at the other inequality, x is greater than 2, so a circle at 2. We don't include it because it's not underlined, so we're not filling it in. And x is greater would go to the right. So then we're going to shade this way. And that is what a graph of a disjunction would look like. And this is only, a disjunction is only true if and only if at least one of its parts is true. So one of those inequalities would have to be true for the disjunction to be true. Then we're going to talk about a conjunction. That's a compound statement that's using the word and. So it's going to look similar, except for it's going to have and in the middle. And if we're not going to see the word and in most of these. You are normally going to see the smallest number written, then is less than or equal to, and then your x or your variable, whatever one you're using, is less than 2. So normally that's how it would look. If you were to kind of pay attention here, this inequality is the exact same as this inequality. It's just flipped around, so the x is second. And then this inequality here is the same as this inequality. So we just combined the two. And in set builder notation, it's going to be written the exact same as the disjunction, except for instead of the word and, you are going to have, with an upright U, you're going to have an upside down U. And then on a graph, a circle at -3. And we're going to fill that circle in because it is underlined. And a circle at +2, and it's going to be open. And x is greater than -3, so we would shade this way. And then x is less than 2, so we would shade this way from the 2. And the part that you want to show is the part in the middle. So ands will shade in the middle, ors will shade out. Basically, you're just shading where did the two overlap. And a conjunction is true if and only if all of its parts are true. So both pieces have to be true for a conjunction to be true. All right, so example 1, we're going to solve each compound inequality and then graph our solution set. So in order to solve this, we're just going to have two different problems that we have to do. So for this one, we're going to -3 on both sides. And we're going to have x is less than 2 minus 3 is -1. Bring down the word or. And then for this one, we're going to divide by 3. So we're going to have x is greater than 3. And then we have to graph this. So circle at -1. And it is open because that inequality symbol is not underlined. And x is less than -1, so less than goes this way. And then x is greater than 3, so circle at 3. Again, that inequality is not underlined, so we're not including the 3, so we're leaving it open. And x is greater would go in this direction for the shading. For part B, same thing. We're going to solve. We're going to divide both sides on this one by a -2. And remember, if you divide by a -2, you have to flip your signs. So x is less than or equal to 5 in this case, and this is an and. And I could rewrite this -4. So those are the same things as those two inequalities. And then this one I'm going to go by 2's. Just to fit everything in easier. -4, circle is open. And this one says x is greater than -4, so we'd have to shade to the right. And then x is less than or equal to 5, which would be right here in the middle. And it's equal to on that inequality, so I'm going to shade that in, and x is less than means I would shade in this direction. And these would overlap here in the middle, so that would be where my answer is. Now I forgot to write the set builder notations on these, so we're going to have to go ahead and go back and do this one and the one before it. So we start with our x here, and then we write our two inequalities. Our first one is x is greater than -4. And remember the and would be an upside down u. And then we can write x is less than or equal to 5. And we could also write it using this inequality. So whichever one you prefer, both of these answers are saying the exact same thing, just look a little bit different. And then if we wrote the interval notation for our graph, we are starting at -4. We're not including -4, so that's going to be a parenthesis. And we're going up to +5, and we do include 5, so that circle's filled in, so we have to have our bracket. Now going back up here to this one, we are going to have, for set builder notation, the x in the line. And then our inequality, x is less than -1. And remember, the ors are a regular u. And x is greater than 3. And then for set builder notation, we're going to have two different pieces. We're starting our largest number here on this portion of the shaded region is -1. And it's not included. And then we're going to the left forever. So remember that was an infinity, and we're going to put -infinity since we're going on forever. There's no stopping. And we can never include infinity. And then we have the u. And then we have to write another interval notation for this piece. So we're starting at 3. It's not included. And we are moving to the right forever. So that's going to be infinity, and we can't include infinity because there's no stopping point there either. Okay. And for part C here, we are going to -3 from both sides. So we're going to have x is greater than 7 minus 3 would be 4. Or this one, we're going to divide both sides by 3. So x is greater than or equal to 6. I have to put that on a number line. So circle at 4. It's not underlined, so we're not including it. And x is greater than 4, so we're going to shade this direction. And then our other one, x is greater than or equal to 6, so circle at 6. And that one is underlined, so we're going to fill that one in. We're including 6, and x is greater, so we're going to shade this way. So since this is an or, it's one or the other one. We started here at 4, and we shaded all the way over in this direction. So anything in the red would be a solution in this case. And then if we have to write in set builder notation, we have the x. And then where are our solutions? Well, they are anything larger than 4. So x is greater than 4 would be any ordered pair on that red line. And then if we had to write this in interval notation, we're starting at 4. It's our smallest point. We're not including it, so it gets a parenthesis. And we're going on forever into the positive numbers there. So we're going on infinitely there. And we can't include that, so it gets a parenthesis as well.